Hello and welcome back to Quantitative Reasoning Online, 13D preview assignment. And let's see, 13D, wait, there's more. All right, I'm excited. Hope you are too. So no further ado, let's go to 13D preview. Last part of this section of 13, so once this is done, lesson 13 will be done. And so with lesson 5, learning plan 5. Understand the characteristic of stratified sampling when using it, when to use the sampling method. That was kind of hinted at when on the last question, in the last lesson. When a stratified sampling is when you want to group your study group in their characteristics, that are logical characteristics, like age, sex, lifestyle habits, diseases. Identify a representative sample by dividing a population into groups, then selecting members from each group. So this is the stratification, and this last part would be the simple random sampling of the group. Understand that larger samples tend to yield statistics with smaller errors. And so as n goes up, accuracy of prediction or inference also goes up. So in the next class, which will be 13D workbook, you will continue to explore populations research studies in different ways to gather representative samples. The tutorial for preview lesson 13, part D. Wait, there's more. Begins here. Okay, select the correct characteristics. Read about the characteristic of stratified sampling at http www.princeton.edu blah 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 HTML and answer the question. So let's do that real quick. Let's pull up this here website. Website not found. Okay. Make sure I have that bullet there. So let's just go and do another different search. Let's just search for stratified sampling. And there's no shortage of it. So definition, it's a type of sampling method in which the total population is divided into smaller groups or stratas to complete the sampling process. When using stratified sampling, the researcher should use simple probability sampling. How's it done? It's the same thing. Example. Stratified example is one that ensures that subgroup, the strata of a given population, are each adequately represented within the whole sample population. For example, one might divide a sample of adults into subgroups by age, and from each of these age groups, you'll select 20 people, 30 people. Let's say that's enough to answer the question. So because some populations have subpopulations that may have different characteristics, and we should make sure that they are all represented. Okay? Because some populations have subpopulations that may have different characteristics, and we want to make sure that the different characteristics do not get represented. Well, the whole idea of doing this is to ensure representation. Because random sampling from the overall population is never a good idea. Definitely not. So we're going to break the populations into subpopulations so we don't represent populations. Okay, that makes no sense. It has to be this guy. So when subpopulation with an overall population vary, it is advantageous to sample each subpopulation, the stratum, independently to address a research question or hypothesis. Stratification is the process of dividing members of the population into homogeneous, logical, appropriate subgroup subsets before sampling. Every element in the population must be assigned to only one stratum. Wow. Basically, we just want to make sure that we want good representation of everyone. Okay. Because a lot of time with medicine, we want to know a question: is this just as effective on men as women? You know, men and women body chemistry are different. So if we want to check medicine, we'll break our population into male and female. Again, what population? Smokers, people on meth, because we want to try meth head treatment, cancer, acid reflux. Okay. So we want to break out and see if we do the treatments, if you get some results. So that's the reason why you want to stratify, is to ensure that whatever you do in the treatment on or observing is representative. One example of a situation in which stratification might be important is our earlier scenario about student satisfaction at community college in your state. Colleges in different communities may have very different characteristics. They may also vary in size. Which sampling method below is likely to yield the most accurate statistics? Have all colleges submit a list of names and addresses of all students at these colleges. Then randomly select 14 names from the list of the survey. So in this case, we have 10 colleges, and of these 10 colleges, we have 20,000 students. So we're going to mix them up and then select 1,400 names. That's basically what they're saying. Problem is, you may get overrepresentation of several colleges and underrepresentation from other colleges. Randomly select an equal number of students from each college in the state. Okay, so you got 10 colleges, and then we're going to, from each of them, let's just say 10. Okay. Randomly select students from each of the college proportional to the size of the student body. For example, if one college student body makes up 5% of all college students, then 5% of the sample should be from that college. It's kind of like what I said earlier. So again, this one should have this should be most, more, less. Okay. So let's see. So again, just to get a, of course, if they're all the same size, we're down to here. Okay. So again, say if you want 1,400 students, 1,400 of them. 1, 2, 3, twice as big. You should have more from this school than this school, and of course that should be more than these schools. So every college should be representative, and large colleges should have more representation in the sample than small colleges. Now, what would be an interesting variation of this study, of this guy, would be satisfaction between large and small schools. Okay. So, I mean, a kind of a fun variation would be your small schools, your medium schools, and your large schools. And do a cluster on them and see if what satisfaction level is among the school sizes. So that'd be interesting one to do. So you may take, I'm not sure what the sample size would be, but just do small schools, see what they are, medium schools, large schools, and compare them. 20%, 5%, 6%, for example. Because people tend to say, "Hey, small is better. You get more personal help." Other people say larger is better because you have more resources. Whatever. But that'd be an interesting study to do, though. Instead of just doing an overall, do a competition between the schools, see which size has more satisfaction. Okay. Now, here's the other thing that's important. In measuring satisfaction, it'll probably be done via a survey, questions. You gotta make sure each school gets the same question, and you're measuring the same level of satisfaction, quality of life, so to speak. More. Okay, here we go. Select correct answer. You have gathered 1,400 students surveyed for your study in question 2 and computed the satisfaction rate. You expect some error. Suppose that you learned that the rate has a 3% margin of error. So the error rate should be within 3 percentage points of the computed value. So 75% plus or minus 3% should be most of the answers. If you're unhappy with the margin of error, what could you do to reduce it? Well, check our calculation, find the error, increase sample size, survey all students at every community college in the state. Okay. Now, one thing you're going to learn is this number is based on sample size. There's a formula for that. I don't think we do it though. So the more n approaches big N, sample versus population, your margin of error reduces. So crazy, if 3% is too big for you, that's really not a bad margin of error. You want a smaller margin of error, increase your sample size. So instead of 1,400, you may have to go to 2,400. Basically doubled it to get it down to maybe 2%. I just made that number up, by the way. All right, hey, we're done. Using the ratings to get it blah, blah, blah. How confident are you that you understand the characteristics of stratified sampling and when to use that sampling method? I'm extremely confident. Okay, you want to use it when you want to ensure all groups are representation of subgroups of the population. The subgroups may have characteristics you want to have specifically looked at, or they have compared to. Again, age, sex, disease. How confident are you that you can identify a representative sample by dividing a population into a group? I think you can do that. And how confident are you that you understand that larger samples tend to yield statistics with smaller errors? That's just one of those fact things going on. Okay, the more samples you have, the more representative of the population. And your sample size approaches population, the error goes basically to 0 because your sample is the population then. But some populations are so large that you got to accept some error. So we talked about stratified sampling and when to use it. That was discussed and that was discussed. So tutorial is done and I'll see you shortly. So again, go look at these guys again and look up stratified sample and simple random samples on your own to get a better feel for it. and I will shortly see you with questions 1, 2, and 3. See you soon.